In this video we are going to discuss about the stereoisomerism. In the earlier video you got to know that when the two or more molecules having same molecular formula but their properties are different due to the change in the structure, hence those are called as structural isomers. But in the stereoisomerism or the stereoisomers, here the structure is also same, means two or more molecules having same molecular formula and their structure is also same, means the attachment of the groups to the particular the carbons or the atoms is same, but their physical and chemical properties are different. Because of that those are called as isomers. Why there is a change even though their structure is same is the position of the groups in the space is different. Okay, means the arrangement of atoms in the space is different. Arrangement of atoms or the groups in the space is different. Because of that these are called as stereoisomers or the stereoisomerism. Okay. There are mainly two classifications, two main groups. One is conformational and the next one is configurational. First we shall discuss about conformational isomers. What are conformational isomers? Conformational isomers, these isomers having same molecular formula and same structures, and these can be interconvertible. Okay, there will be two types of molecules, these can be interconvertible, so these are called as conformers. These type of molecules are also called as conformers. Okay, because of the interconvertibility of the two isomers or the two molecules, these cannot be separated, means you cannot isolate these isomers. Again the conformational isomers are subdivided into two. First one is rotational about carbon-carbon single bonds and second one is amine inversion. First we shall discuss about the rotational about carbon-carbon single bond. So here you can see these rotation about carbon-carbon single bonds in two projection formulas, means two types of studies, that is projection is called as projection formulas. One is Newman projection and Sauer's projection. See, this is, consider it is a ethane molecule. This is carbon atom. So ethane molecule means CH3. Ethane is carbon-carbon single bond and this carbon is having 3 hydrogens and this carbon is having 3 hydrogens. Let's see what is rotation about carbon-carbon single bonds of this ethane molecule. So we can see that this is Newman projection formula. This point is called, this is considered as carbon. This is one of the carbon and the bigger circle is the another carbon which is behind this carbon atom. Means let's consider this is carbon number 1 and this is carbon number 2. This is carbon number 1 and this is carbon number 2. Okay, so carbon number 1 is attached to 3 hydrogens and carbon number 2 is attached to 3 hydrogens. When you rotate this, when you have to hold this carbon number 1, you have to hold this carbon number 1, you have to rotate this, the behind carbon, this means the second carbon atom, about 60 degree. See, when you rotate this about 60 degree, this hydrogen come exactly behind to this hydrogen and this hydrogen comes to behind this hydrogen and this hydrogen go to behind this hydrogen, so that this form is called as eclipsed form. When this form is called as staggered form and this form is called as eclipsed form or eclipsed conformation. And this is more stable. Staggered conformation is always more stable because there is a less hindrance between this hydrogen and this hydrogen. There is a much space between this hydrogen and this hydrogen, so that this is more stable when you compare to eclipsed conformation, because this hydrogen is exactly behind to this hydrogen, hence there is a more hindrance will be there, so that this eclipsed conformation is less stable. This is less stable than the staggered conformation, which is more stable. Okay, this is Newman projection. Hence, the next one is Sauer's projection. Here also same. This is carbon number 1. This is carbon number 1, and this is carbon number 2. When there is no hydrogen behind this hydrogen, and there is no hydrogen behind this hydrogen. Here also there is no behind this hydrogen. Means these hydrogens are in between these hydrogens. This hydrogen is in between this hydrogen, and this is in between this. Okay, and this is called staggered. So hence there is no hindrance will be there. Hence these are more stable than the eclipsed. When you rotate this, when you hold this carbon atom, and when you rotate this carbon atom, this is called carbon-carbon rotation. Carbon-carbon rotation about CC bond. You have to rotate. This is a carbon-carbon single bond. You have to hold this, and you have to rotate this so that about 60 degree, so that this will come here. See, after rotation, this will come here, and this will come here, and this will come here. See, this is the eclipsal conformation, and hydrogen is behind this hydrogen. This hydrogen is behind this hydrogen. This hydrogen is behind this hydrogen, so that the steric hindrance is more here in this eclipsal conformation. Hence, this is less stable than the staggered conformation. Okay, let's understand this by models. See, this is ethane molecule. This is ethane molecule. This is carbon number 1 attached to three hydrogens, 1, 2, and 3. This is carbon number 2. This is carbon number 2 attached to 3 hydrogens, 1, 2, 3. Okay. This is called as staggered conformation. See, there is no hydrogen behind this. There is no hydrogen behind this, and there is no hydrogen behind this. Okay, this is staggered conformation. This is staggered conformation, and when you rotate this about carbon-carbon bond, this is rotation about carbon-carbon single bond. When you rotate this about 60 degree, see the rotation. See, this is eclipsal conformation. This hydrogen is exactly behind this hydrogen. This hydrogen is exactly behind this hydrogen, and this hydrogen is exactly behind this hydrogen. So here the hindrance is more, so that this staggered conformation is less stable than the earlier, that is this eclipsal conformation is less stable than the earlier staggered conformation. This is this is eclipsal conformation, and again when you rotate this about 60 degree, you are going to get the staggered conformation. See, there is much space between this. There is no hydrogen behind this. Hydrogen are in between this. Okay, this is called staggered. Again, when you rotate this, again you are going to get the eclipsal conformation. Here, the steric hindrance is more. Hindrance due to this hydrogen is more. So this is less stable. Okay. Let's see another example, that is butane. This is structure of the butane. Butane is CH3, CH2, CH2, CH3. Okay, this is one CH3. This is CH3. This is CH2. This is C, and here H2. And this is third carbon atom, means carbon containing CH3 and CH2. This is the third carbon atom containing CH3 and CH2, and that CH2 is containing one CH3 and 2 hydrogens. Okay, when the CH3 is behind this CH3, and hydrogen is behind this hydrogen, and this hydrogen is behind this hydrogen, this is called fully eclipsal conformation. Means there is a more steric hindrance between this due to this CH3 and CH3. Hence, this is called fully eclipsal conformation. When you rotate this, the behind CH3, you have to hold the carbon number 2, and you have to rotate the carbon number 3 about 60 degrees Celsius, 60 degree. So the behind CH3 will come to about 60 degree. Rotation comes here, and this hydrogen goes here, and this hydrogen goes here. So this is 60 degree rotation. Okay, this form is called as Gauche form. This is staggered form. When the CS3 is next to this CS3, nearer to this CS3, this staggered conformation is called as Gauche conformation. And again, when you rotate this CS about 60 degree, this CS3 come behind this hydrogen, this goes behind this hydrogen, and this goes behind this CS3. This is called eclipsed conformation. It is partially eclipsed because in the earlier case the CS3 is exactly behind the CS3, hence it is fully eclipsed. But here the CS3 is behind this hydrogen, hence it is partially eclipsed. When you again rotate this CS3 which is there behind this hydrogen, that comes to here, and this hydrogen goes here, and this hydrogen goes here. So this CS3, we are going to get this form. This CS3 is opposite to this CS3. So there is a less hindrance. There is a less hindrance between this CS3 and this CS3. This CS3 and this CS3. Hence this is called anti-form, anti-conformation. This is also staggered conformation, less hindered staggered conformation. Hence it is called as anti-conformation. Okay, let's understand this by the models. See, this is butane. This is considered, this is CH3, CH2, CH2 and CH3. CH3, CH2 containing two hydrogens, CH3, CH2 and CH2 containing two hydrogens and one other CH3. Okay, let's see the eclipse. Eclipse means this CH3 is behind this CH3. See, these CH3s are very nearer to each other. This is fully eclipsed form. Hence there is a more hindrance will be there between this CS3 and CS3. When you rotate this about 60 degree, you are going to get the staggered form. In the staggered form, this CS3 is, there is less hindrance between this CS3 and this CS3. Hence this form is called as Gauche form. This form is called as Gauche form. Again, when you rotate this, you are going to get the eclipse conformation. This CS3 is behind this hydrogen, and this hydrogen is behind this CS3, and this hydrogen is behind this hydrogen. This is called partially eclipsed. This is eclipsed, but the steric hindrance, the hindrance between the CS3 and CS3 is very less, hence it is partially eclipsed form. Again, when you rotate this about 60 degree, you are going to get this form. You are going to get this form. Okay, you are going to get this. You are going to get this form. This is anti-form. See here, this is anti-form. These methyl groups are anti to each other, hence this form is anti. There is a more difference, hence the hindrance between the CS3 and CS3 is very less, hence this is called as anti-form. This is the staggered anti-form. Okay, let's discuss the stability here. In the earlier case, we got to know that in the ethane, we got to know that the staggered conformation is stable than the eclipse, because in the CS3 are very nearer, hindrance is more, it is less stable than this. Here, when there is fully eclipsed, CS3 is behind this CS3, hence it is less stable, means least stability, it is least stable. In the anti, the CS3s are away from each other. CS3s are away from each other, hence this is highly stable. See, anti is highly stable, then the Gauche, then the partially eclipsed, and then finally fully eclipsed is least stable. First one is anti-form is highly stable, the next Gauche form is stable, and third is partially eclipsed, and finally this is the least stable, that is fully eclipsed form. And also we can write the cyclohexanes in chain form. This is chair form, and this is boat form, and this is twisted boat form. This is twisted boat form. A chair form is highly stable than the twisted boat, then finally the boat form is least stable. This is about the conformational isomers. The next, amine inversion. This is amine inversion. In the amine inversion, amine is always in the inversion state, means this is sp3 hybridized nitrogen. This is always converted to this state, means there is a inversion takes place, rapid inversion through this transition state, and again this will invert to this form. There is a rapid inversion from this to this, and again this to this through this transition state. This state is sp3 hybridized. These two states are sp3 hybridized, and this transition state is sp2. And this is the sp3 is containing the pair of electrons. Here also sp3 containing pair of electrons, but here the p orbital is in the transition p state. P orbital is vacant, hence it is sp2. It is always in the inversion state, rapid inversion. So that because of the rapid inversion, we cannot isolate these isomers. We cannot isolate this and this. Let's see. This is, consider this is nitrogen. Consider this is nitrogen. This is containing 3 atoms, 3 groups, and consider this is a sp3 orbital containing pair of electrons. It is from this, it is converting to this form, means there is an inversion takes place. This invert to like this, again this invert to like that. Okay, there is a rapid inversion from this state to this state through this transition state. Hence this is called as amine inversion. Thank you.